How do electric vehicles work? Since they run mostly on electricity rather than conventional fossil fuels, electric vehicles mark a revolutionary change in the automotive industry. Electric motors and EVs are powered by rechargeable battery energy, giving them instant torque and effective operation. EVs have fewer moving parts than cars with internal combustion engines, which mean they require less maintenance, produce fewer emissions, and are quieter to drive. In this video, we will show you how electric vehicles work. Electric power source. Electricity stored in rechargeable battery packs, which are usually composed of lithium-ion cells, powers electric vehicles. Because of the large amount of energy that these batteries can hold, the car can go a long way between charges. The vehicle's range is directly impacted by the battery's capacity, which is expressed in kilowatt hours. The performance and range of EVs are improved by manufacturers' continuous efforts to increase energy density, a result of advancements in battery technology. Because the batteries are often placed in the floor of the car, handling and stability are enhanced by the low center of gravity. Because of their extended cycle life, low self-discharge rate, and high energy density, lithium-ion batteries are the preferred option. They are ideal for automotive applications because, in comparison to other battery types, they are also comparatively lightweight. To guarantee safety and avoid overheating or overcharging, which can result in decreased performance or even a fire hazard, lithium-ion batteries must be carefully managed. To reduce these risks, the battery pack must be monitored and controlled by the battery management system. Electric motor. Electric motors are used by electric vehicles to transform electrical energy into mechanical energy for propulsion, as opposed to internal combustion engines which burn fuel to generate power. Instant torque from electric motors enables quick acceleration and comfortable driving. Electric motors are very responsive because they produce power instantly, in contrast to conventional engines that take time to develop power. This feature adds to the fun driving experience that EVs are frequently associated with. There are several different kinds of electric motors, such as switched reluctance motors, permanent magnet synchronous motors, and AC induction motors. Regarding cost, power density, and efficiency, each type offers unique benefits. The most popular kind of induction motors are AC models, which combine affordability and high performance well. Although they are typically more expensive, permanent magnet synchronous motors offer even greater efficiency and power density. Although switched reluctance motors are renowned for their dependability and simplicity, their efficiency may be inferior to that of other varieties. The vehicle's unique needs, including those for power output, efficiency, and cost, will determine which motor is best. Inverter functionality. A key part of an electric car is the inverter, which changes the direct current electricity stored in the battery into alternating current electricity that the electric motor can use. Since most electric motors run more efficiently on AC power, this conversion is necessary. By modifying the frequency of the AC power supplied to the motor in response to the driver's input from the accelerator pedal, the inverter also contributes to the control of the motor's speed and torque. It is possible to accelerate and decelerate smoothly thanks to this exact control. EV inverters are usually made to be small, light, and extremely efficient in order to reduce power losses and increase the range of the car. To do the DC to AC conversion and manage the motor, they use cutting-edge semiconductor devices like metal oxide semiconductor field effect transistors or insulated gate bipolar transistors. The overall performance and efficiency of the electric drivetrain are largely dependent on the design and efficiency of the inverter. Controller system. The controller system controls how energy is transferred from the battery to the motor and other parts of the electric car, functioning as its brain. It ensures that the car reacts to acceleration and braking quickly and precisely by interpreting the driver's commands and adjusting the power output accordingly. The controller also keeps an eye on a number of vehicle parameters, like temperature and battery condition, to maximize efficiency and performance. In addition to improving overall driving enjoyment, this advanced system helps keep the car safer. The accelerator pedal position sensor, wheel speed sensors, temperature sensors, and other sensors located throughout the vehicle provide input to the controller system, which is usually a microprocessor-based device. The controller determines the proper power output based on these inputs and provides control signals to the inverter and other parts. In order to guard against damage to the electrical components and guarantee dependable operation, the controller also includes safety features like thermal management and overcurrent protection. To further improve the vehicle's performance and safety, advanced controller systems may also come equipped with features like traction control, stability control, and regenerative braking control. Regenerative braking, which enables the vehicle to recover energy during braking, is one of the unique characteristics of electric vehicles. The electric motor changes into a generator and transforms kinetic energy back into electrical energy when the driver applies the brakes. This procedure aids in battery recharging, increasing the car's range and enhancing overall performance. Regenerative braking is a crucial component in optimizing the performance of electric vehicles because it not only improves the energy management of the vehicle but also lessens wear and tear on conventional brake components. In order to slow down the car, the regenerative braking system applies a reverse torque to the wheels. The electricity generated by the motor, which functions as a generator, is redirected into the battery pack. The vehicle's controller system regulates the amount of regenerative braking force applied by considering various factors like the driver's braking input, the vehicle's speed, and the battery's state of charge. When driving downhill or in stop-and-go traffic, regenerative braking is especially useful as it allows the vehicle to recover large amounts of energy that would otherwise be lost as heat through conventional braking systems. Charging options. Owners of electric vehicles have flexibility in the ways they can charge their vehicles. The slowest option, level 1 charging, uses a regular 120 EV household outlet and can charge a device up to 3 to 5 miles per hour. Home charging stations typically use level 2 charging, which uses a 240 EV outlet and can deliver a range of 10 to 60 miles per hour, depending on the vehicle and charger. Public charging stations typically have DC fast charging stations, which can add 60-80 miles of range in 20-30 minutes, which is a significant amount of range in a short amount of time. It is convenient for EV owners to refuel their cars thanks to the range of charging options available. Since level 1 charging only needs a regular household outlet, it's the easiest and most accessible option. Since it's the slowest method, owners with short daily commutes or those who want to charge overnight may find it suitable. Because it offers a faster charging rate, level 2 charging is more prevalent for charging stations at homes and workplaces. Level 2 charging is available for many EVs, and homes and workplaces can install specific level 2 charging stations. DC fast charging stations are usually found in public areas like retail malls, rest areas along highways, or charging plazas specifically designated for that purpose. Battery management system. The battery pack of an electric vehicle depends on the battery management system for performance, safety, and longevity. It keeps an eye on the temperature, health, and charge level of the battery to avoid overcharging or deep discharging, which can harm the battery. In order to maximize efficiency and prolong battery life, the BMS also evenly distributes the charge among the individual cells in the battery pack. The BMS is essential to preserving the vehicle's dependability and efficiency because it controls these crucial elements. A microcontroller, temperature sensors, voltage and current sensors, and other parts make up the BMS. The sensors in the battery pack are always keeping an eye on the temperature, voltage, and current of each individual cell. To guarantee secure and effective operation, the microcontroller analyzes this data and makes decisions. The BMS can take corrective action, such as lowering the charging or discharging rate, or in an emergency, disconnecting the battery from the vehicle's electrical system if any cell surpasses predetermined voltage, current, or temperature limits. Cell balancing, which involves adjusting each cell's charge level to avoid imbalances that can result in decreased capacity and a shorter lifespan, is another function carried out by the BMS, and to provide an early warning of possible problems. These ideas give a thorough grasp of the different parts, advantages, and functional aspects of electric vehicles, as well as how they operate. Thanks for watching our video, and don't forget to subscribe.